All right, guys. Beautiful evening to you. All right, I can see you. Miracle, I can see Adeshina. Okay, I can see you guys there. All right. Happy Sunday, everyone, and happy new week to you. In this video, in this tutorial, in this class, do you like by the way, do you love is it okay? Are you okay with the feed? Are you getting the right thing from your hand? Are you okay with this? Okay. All right. So today is for trigonometry, and we're going to delve into some few questions, and I believe uh, at the end of today's tutorial, you would be a pro in trigonometry. Uh, we'll be solving the very first question right now. And all right, so we're told to solve this trigonometry equation. 1 plus 2 sine theta plus 25 equals to minus, okay, there's no minus there, 2.532. And you were told that the value of theta is ranging from 0 to 360. So theta ranging from 0 degree to 360 degree. So this is the very first question we want to solve in today's class. And I'm sure you guys have seen this question somewhere. And I'm hoping at the end of this class, you'll find it very simple. All right. What do you think will be our very first step? Well, I'm sure you guessed right. When you're dealing with mathematics generally, you want to start from dissolving all the things you can dissolve easily. So when I say a question like this, the very first thing that comes to my mind is, okay, before I go into all the complexities, let me first do the things that are very much conspicuous to do. So when I have 1 here and I have 2.532 here, I can decide to just collect like terms and make it 2 sine theta plus 25 degree will be equals to 2.532. I'll cross this over here minus 1. So we have 2 sine theta plus 25 will be equals to 1.532. So that's the very first step that I think we should all be able to do. Okay. Now, what's the next thing you can see that can be easily solved in this particular question? I can see 2 right here. If I decided to divide both sides by 2, that means I divide both of the left-hand side by 2. And if you divide the left-hand side by 2, you have to do the same for the right-hand side. So dividing both sides by 2, I'll have sine theta plus 25 degree will be equals to, what is 1.532 divided by 2? be having 0.766. 0.766. All right. Now, this is the place where you have to pay real attention, because I'm sure this is where some students will get it confusing. Now, in some of the questions you may have seen or may have been familiar with, you used to have something of this sort where you are dealing with. In this case, you'll be having like maybe sine theta equals to 0.766. Then, or maybe cos theta. So you used to have just cos being the angle. But in this case, you are told that the angle is not just theta. So theta here is not what you are going to call the angle. This whole thing is the angle. You need to be mindful of that. This whole thing is the angle. The angle is not theta alone in this case. So don't isolate theta from this place. You cannot isolate theta here because this is the whole angle. And don't forget, when you say sine theta, or imagine you say sine theta plus 25, you cannot go on to say sine theta equals to, let's say there was a 1 here, and say 1 minus 25. That's wrong. You cannot go on to say, I want to move 25 away from here, because this whole thing you have here is associated with sine. And you can't throw theta away, you can't throw 25 away. It's like glued onto sine. So the only way you can solve this equation, if you had it like this, was for you to say theta plus 25 will be equals to arc sine 1. So that's the only way. You cannot dispatch 0 and 25 in this particular place when you were at this position. So you have to only resolve by finding the sine inverse. So that's the best step to take in order for you to resolve the question. So that's where you need to pay attention. So you can't go on to, you need to resolve this by saying theta plus 25 degree. Theta plus 25, everything is the degree there, will be equals to arc sine 0.766. This is the logical, ideal way to go about solving this problem. Now, I remember explaining something around angle of any magnitude. And I told you that when you get to this particular position, this step right here, this particular step, I told you that what you're supposed to do here is to act like as if you are not minding the sign, either it was plus or minus. So you will go on to do what we just did. You will find either the arc sine or the arc cos or the arc tan, depending on whatever question you're dealing with. Then you will then go on after getting that answer to then go and check your quadrant to find the final answer. So if you go on to do what we are doing right here, this step we are doing is basically that step I used to tell you to do, ignoring the sign. So we have ignored the sign here. We're not caring if there was a plus or minus here. We just wanted to find what our theta plus 25 degree is. So our theta plus 25 degree, if we do arc sine of 0.766, what do you think you're supposed to get there? What is arc sine of what you have right there? Well, arc sine of that should give you something around 50 degree. Is that correct? 50. All right. So we have 50 degree. Arc sine of this is 50 degree. So now, please pay real attention here. This is very crucial. I can then go back to this step right here, this particular step, and then go and check what was the sign associated with sign here. What's the sign here? I can say the sign here is obviously a plus sign because there is no minus there. So I know already that my theta is positive in the first and second quadrant. So theta is positive in the first quadrant. Theta is positive in the second quadrant. What I need to do now is to, first of all, remember, I told you when you are dealing with the first quadrant, all you have to do is to replicate what you have gotten here. So I can go on to say, replicate whatever you have gotten here initially. Now, while you are dealing with what you have here, don't forget that if it was the second quadrant, the rule for the second quadrant is 180 minus theta. Now, before you go on, we can find our theta from this particular position now. Our theta will be equals to 50 minus 25, which will be equals to 25 degree. So we have gotten a value for theta at this point. Now, this is our theta, 25 degree. Can we then go on to find for the second quadrant? The rule for the second quadrant tells us that we are dealing with 180 minus theta. That will be 180 minus 25. 180 minus 25 will be 155. So to solve for theta, because you're supposed to solve for theta. To solve for theta, we have gotten our theta to both be 25 degree and 155 degree. So our value gave us 25 degree and 155 degree. So if you can see the process, you would understand that it's the major step to take note of is right here in knowing how to use a compound situation like this. So what you must do is to use the whole thing and then find the arc sign. Don't try to dissolve this until you have found the arc sign. So after finding the arc sign and you have been able to eliminate the sign now, then you can then go on to be resolving for theta, which you later now got to be 25. And then from there, you can go on to resolve for 180 minus theta, which is now 180 minus 25, which is 155. Does this make sense? I believe it does. So I think we can move on to the next question for the day, for the night. I don't think anybody is writing. Okay. How many of you got this question? How many of you got the answer? Show of yourself, you got this answer. You got this exact answer. Now you're supposed to resolve this particular question. We're supposed to resolve this particular question. Probably one of the simplest questions you would ever meet under trigonometry. And don't forget, the value for y here is given to be between 360 and 0 So how do we go on to resolve this? This is a very simple question. Number one, you need to understand all your identities. That's what will give you a very big edge in solving this question. Now, looking at what we have here, I can see that cos y is here, cos y is here. This is 2 cos y, this is 5 cos y. So I don't need that level of complexities in my question. So what I want to do is to resolve that by, I want to move that to one side. So I'll be having 2 cos y minus 5 cos y. So this will be 2 sin y equals to minus 3 cos y. So that's the very first step. That's the very first step, is solving that. Now, what do we do next? What we have to do next is to, can anybody see what can happen right here that will give me, the idea around trigonometry equations, which I told you earlier, is that you don't want two different trigonometries in your question. You always want to ensure that you just have one particular trigonometry. Probably you want just sine, you want just cos, you just want tan. It has to be just one. So now we're seeing sine, we're seeing cos. So how do you feel we can put this on just one particular trigonometry? What do you think we have to do for us to bring this to just one particular trigonometry? Somebody said substitute. What are we going to substitute here? Well, let me tell you what you have to do that will be much more easier than any form of substitution. If I decide to divide both sides, by cos y, let's see how that goes. I want to divide both sides by cos y. Dividing through by cos y. Divide through by cos y. What do I have? I will have 2 sin y over cos y equals to what? Minus 3 cos y all over cos y. What do you think is going to happen when I do this? Of course, this cos will cancel this cos, but this cos cannot cancel this sine. But what is sine y over cos y? Don't forget the identity that told us that the tan of an angle, of any angle, is equals to the sine of that angle over the cos of that angle. So obviously, having sine y, the sine of an angle y, over the cos of an angle y, will give me 2 tan y. And that will be equals to minus 3. Do we see how interesting this is? We can literally see that we have been able to bring this from this very complex looking equation, and this is what we have been able to resolve it into. So from here, we have to follow through on the idea around solving trigonometry equations. So what I have here, I have tan y. So I want to go on to make tan y the subject of the formula, I have tan y equals to minus 3 over 2. Obviously, I divide both sides by 2. So that's the very first step. You have tan y equals to minus 3 over 2. In decimal, minus 3 over 2 is going to be what? That will be 1.5. So I can say tan y equals to minus 1.5. Now, this is good, but what we have to do next is to find a way to find for y. Don't forget, when we are told to solve a particular equation, we are supposed to find the unknown variable. So now we have y as our unknown variable, and we want to resolve for heat. So what do we do next? We have tan y equals to minus 1.5. I told you already that the very first step to take is to go on and decide to ignore whatever sign we have here, either positive or negative. Here we have negative. If we had positive, it will not matter. We'll just go on to find tan, arctan. So let's go on to do that here. So my y will be equals to arctan 1.5. I will ignore the sign. So what is arctan of 1.5? Arctan of 1.5 is 56.309. .309. So this is important, but this is not where our answer. This is what we're going to use to get our final answer, but this is not our final answer. So we then go on to ask ourselves, where is tan positive? Sorry, is it positive? No, tan is actually negative. So where is tan negative? Looking at the sign here. So we can see that from our quadrant, tan is negative in what quadrant? Is negative in tan is negative in both the second and the fourth quadrant. These are the two quadrants that we have tan being negative. And the reason why we're studying for when tan was negative was because of this particular sign. If this was positive, then we'll be studying where was tan positive. So where is tan negative? Tan is negative in the second and fourth quadrant. So what do we go on to do? What's the rule that happens in the second quadrant? The second quadrant, what we have is 180 minus theta. But in this case, we're not dealing with theta as our angle, we're dealing with y. So that'll be 180 minus y. And that'll be 180. We've gotten our y value for what we're going to be using. That's it right here, 56.309. And that will be equals to what? 180 minus 56.309 will give you a value of 123.69. Now, this is one of our answer, this particular answer. For the fourth quadrant, what is the operation that takes place in the fourth quadrant? We have the operation as 360 minus y, because the angle we're dealing with right here is y. So we would not be using theta here because we're dealing with angle y. Don't forget again, this is our y value. This is the y value we'll be using. So what we have here will be 360 minus 56.309. And that will give me my value as 303.69. So you can see right now that we've been able to solve this particular equation, and we got the two answers for our y as 123.69 and 303.69. So this is the solution to this particular question. Don't forget, this particular y value that we have here is not part of our answer, majorly because this is what we just used to move towards the right answer, because our value for theta being, our y being negative, will make us not to be able to use this particular answer. If we add our angle here being positive, then we would have been able to make use of this particular answer. So this is our final answer for y. So I really hope this question was very clear to everyone. So I'm hoping you are getting the best from listening. So I don't know if anybody is still writing, but I would love to go to the next question. All right, let's try and resolve another question. So this question looks like the very first question we solved, where we have cos 2 theta plus 25. We have to solve this. In this case, it is equals to minus 0.454. And again, we are told that the value for our theta is ranging from 0 degree to 360 degree. This is the reason why we don't just go on at this point to just say arctan, why we have to go and resolve using the quadrant, because of this particular condition we're given. Yes, everything should be in your notes. For that person asking, I think I already gave the announcement, both our class yesterday, the mathematical induction, everything must be written in your notes. All right. Do anybody wants to attempt this? Or do you have your answer already? How do you go home in solving this? For those of you having questions to ask, I can see someone asking, what about just writing minus 56 as the angle? Minus 56, that's not the way you approach this solution. So what I would say is, if you are still having a lot of issue, I think you should just probably find a way to contact me and see me personally, so I can shed more light on that. So, but we can't write minus 56 as the angle. By the way, I would be trying to do a more definite videos on trigonometry, and you should be seeing it sometimes this week. So probably that person will be able to get the procedure from those videos. So what we're doing in this particular class is to solve more questions that would shed more light on trigonometry. All right, I'm sure some people are there, and I'm sure you've started making progress in solving this question. Well, I will keep solving, you can keep solving yours, and we'll see. You will check back to be sure if your answer is correct. You can go on solving yours, but you can also pay attention whichever one feels right to you. All right, let's see those answers I'm seeing. I can see 43.9, 316.1. I can see those answers being written. Let's go on and solve, and then we'll know if those answers are correct. All right, what you have here looks like the very first question we answered. What you're supposed to do here is to just, initially I told you, you're having cos, you are having this question. Look at the question, very simple. You're having this question. One thing I need to tell you is that I said it before, let me say it again. You cannot isolate any value here. You cannot go on to say you want to move 25 here or anything out of this place, because this particular compound angle it belongs to cos. It's not only 2 theta that belongs to cos or maybe 25. They all belong to cos together. So you don't want to separate them. The only way you can go on to solve this is, in this case now, we don't have to do too much because we don't have anything before this particular thing. So what we have to just go and do is to start solving immediately. That means to start resolving using angle of any magnitude. So I asked myself, the first thing to do when I will check the sign here, this is minus. But before I check the sign, I want to go on to first do my arc cos. In that case, don't forget, I told you, you must ignore the sign when you are trying to do the arc cos. Whether it was positive or negative, it will not matter. Just go on to do 2 theta plus 25 degree will be equals to arc cos 0.454. You see, in this case, I ignored the sign. So that's the very first thing you will do. You ignore the sign. And don't forget, this answer is not your final answer. So when you find arc cos of that, you should get an answer of maybe 62.999 or thereabout, which we can easily approximate to 63 degree. All right, so that's the very first step. Then let's now go on to solve using our quadrants. So we have a negative sign here. Seeing we have a negative sign here, we know we are looking for where cos was negative. So from your knowledge of the quadrant, where do you have cos being negative? Well, we have cos being negative in both the first quadrant, the second quadrant and the third quadrant. Cos is positive in the first and the fourth. So it's negative in the second and the third. So what's the rule that operates? Of course, from this place, you can go on to initially find your theta. What's going to be your theta right here? Your theta from 2 theta plus 25 equals to 63. You can find your theta there. Your theta there being well, whichever way you decide to move, you will always arrive at the same answer. So what I want to do for this particular one is to this is your theta. This is like your angle. I can go on to use this as 180 minus 63, and that will give me what? Don't forget, again, that's not going to be the final answer. What is 180 minus 63? That is 117. Now, 117 is not your final answer. Just note that, because sorry, I'm trying to use my calculator right here. So what I can have here, this is just for more like this was the angle. So I'm using this as like the angle here, but don't forget this was the whole representative here. So for me to find the final answer under this one, I would have 2 theta plus 25 degree was equals to 117. So from here, I would have to resolve for my 117. That will be 2 theta equals to 117 minus 25. 2 theta will be equals to 117 minus 25 will be 92. And if you go on to use your calculator here, you will get your theta to be 46 degree. That's just for the second quadrant. For the third quadrant, what we have is theta plus 180. In this case, don't forget, this is like the same, this is what we'll be using as the theta here. This is what we have here, because this whole angle is seen like when we used to have theta. If this whole place was theta, when we used to have theta, that's what this angle is seen as. So we can go on to say this is 63 plus 180. 63 plus 180 gives us 243. Now, from what we have here, we are dealing with not just a single theta now, we're dealing with this whole thing. So we have 2 theta plus 25 degree plus 25, let me just leave it at that, equals to 243. So if I go on to resolve this, 243 minus 25, that will be 218. Let me manage this space right here. So this will be 2 theta equals to 218. Dividing both sides by 2, I will have my theta to be 109 degree. So looking at this, I've been able to get two of my values of for theta. Number one, I got theta to be 63 degree. Number two, I got theta to be 109 degree. So that's going to be my value for theta. 46 degree and 109 degree. So this is the way we go around solving trigonometry equations, especially when we are having compound angles. When I say compound angles here, I'm referring to, or maybe I should say complex angles where we don't just have theta being represented. So what you go on to do is to take this whole thing more like as you was going to take theta. So taking theta, the way you used to handle theta is the same way you handle this whole thing. So you won't be handling, trying to say, I want to isolate 2 theta. No, you will handle the whole thing as one particular angle. And then you go on to solve. You see, we went on to solve our work normally. Like, imagine this was only theta here. This was what you were going to do. Now, you were done doing that. Don't forget, when you wanted to solve normally, when you had theta, you were going to say, let me first go on to find theta, the initial theta that you used to find, neglecting the sign. That was what we went on to do here. So we neglected the sign here, we got 63. But don't forget, this 63 don't have to be part of our answer, just as you have known before. So the same way we're going to handle when we're dealing with, if this was theta that was here, if this whole 2 theta plus 25 was just theta, what we're going to then do was going to go and ask ourselves, where is cos negative? So we discovered that cos was negative in the second and third quadrant by our understanding of the quadrant and how it works. And the operation that functions in the second quadrant is 180 minus theta. Now, the same way you used to solve when this, if this place was O theta, was that you were going to bring this value and say 180 minus that answer, and you say that was going to be your final answer. So we went on to do that, saying 180 minus this, then we got 117. Now this 117, don't forget, it's not for just theta alone. This was the angle that was being represented all along. So what then do you go on to do? You go on to resolve for theta, because don't forget theta, even though we had it being complex like this, but when they say you should solve, what they actually meant is for you to find the exact value of theta, although it was in a complex form initially. So we are still on a journey of finding our theta. So after getting, don't forget, this whole thing now was what we got as 117, because it was this whole thing that represented 63. So we used it with 63 degree, and then we were able to get 117. Then we had to know that this whole thing now will be the 117, because it's what represents our angle. So after we got that, then we went on to resolve for theta, and we got our theta to be 46 degree. This is one of our final answer, but not the final one. So not the whole thing. We still have one other answer. Don't forget, it's not only in the second quadrant we have theta being, cos being negative. We also have it being negative in the third quadrant. And the rule that functions in the third quadrant is theta plus 180. Now, in this case, don't forget again, this theta plus 180 is a general rule, but that was, we used to use this in previous work when we had this place as just theta. What I'm saying there is that imagine what you had here was just cos theta equals to minus 0.454. Imagine this was what you had. Imagine this was what you had. Now, cos theta was that. So you were going to be using this theta, but now you don't have just one theta. You have this complex angle. So what you go on to do is to act like you were using this 63 now is representing this whole complex thing. So 63 now was used inside our rule for the third quadrant, but what we got 243 is not representing just a single value of theta, it's representing this whole thing. So we then went on to say, okay, the 2 theta plus 25 is 243. Then from here, we're able to find our theta to be 109. So you need to balance yourself with the understanding that this particular thing, when you have a question like this, act like as if that was the angle theta, and everything you are going to do when you were solving for theta is what exactly you will be doing down the line. You will not mix things up. So that's how we're able to get our values for theta to be 46 degree and 109 degree. Okay, I'm trying to check the comment section. I want to know what you guys are saying. If somebody said, how is it complex 29 plus 25? Are you answering somebody or are you asking me a question? Okay, so this is the way we are going to handle questions that has angles like this. Make sure you always deal with them like you were going to deal with theta. So let's try and solve one more question before the end of this class, and let me see how you guys fare with it. Okay, you're asking me a question. What is 29 and where did you get 29 from? Where did you get? Oh, somebody is asking the range was 20 plus 25. This is not 20. Oh. This is 2 theta. This is 2 theta, please, not 20. Oh, you're seeing that as theta. This is not 20. This is 2 theta. All right. Does that make sense to you? 2 theta plus 25, not 20. 2 theta plus 25, not 20. I guess that was an oversight. It's 2 theta plus 25. Okay, is that clear to that person? So I'm trying to check. Yeah, it was 2 theta. Okay. Is somebody asking me a question I've not answered there? Just in case. We want to solve the last question for the night. And I'm hoping that at this point, you guys should have gotten better in trigonometry. Yeah, that's exactly what you're asking. Whoever is asking that question about 2 theta, that's exactly why you have to solve it the way I explained it, because it is complex. It is not just a single theta, it is multiple. It is 2 theta plus 25 will be, you will act like I say 2 theta plus 25 is the whole angle. 2 theta plus 25 as the whole angle rather than just when you used to have just theta. Now look at this particular question. You have 2 sine x, 2 sine square x. Okay, what if the range was greater than 360? How would you solve it? Well, for this particular A level, your range is not going to be more than 360. But you can have a range of more than 360. There are other situations where you have a range of 0 to 720. So that's not going to be a problem. There are techniques to solving that, which we can talk about privately later, because I'm trying to stay on the syllabus for this particular A-level exam. I don't want to go outside it, but it's obviously very possible to solve. So now we have this very simple question. I'm sure everybody can solve this. You can move through different directions and still get your answer with this particular question. You can move through different directions and still get your answer. So I don't know if you want me to use just one, or you want me to go on with solving using several approaches. But let me just decide to use just one initially, and let's see how we go from there. Now look at what we have here. If you don't know your identities, this question could pose a challenge. First of all, there are 2 major identities you have to use here. Number one, you have to use your basic identity. And your basic identity said that sine square of an angle plus cos square of another angle is equals to 1. This is one of the things your basic identity said. Now, there's another identity for double angle that said if you have the cos of the double angle of a double angle, you are going to have this. Now, don't forget, somebody else may decide to write this double angle as 1 minus 2 sine square x. I think I gave you all these differences. Now, depending on what you decide to use, make sure the very first thing I told you when trying to solve trigonometry equation is that make sure that you have just one trigonometry in your equation. Now we have cos and we have sine. This is not good. We want to bring this to just one. So how do we bring this to just one? What we have to do is to tell ourselves the identities we want to use. I can say sine square x here. I can decide to take sine square x to be equals to 1 minus cos square x from this particular identity, because I can see that this is an identity which you should know. So from here I can see that sine square x is 1 minus cos square x. Now the reason why they want to do this was because I wanted to use, if I'm using this as this, sine square x as this, that means I want to use cos all through. So I want to use cos all through. So now I go on to write 2. Now I'll be having, let me go on to start it under here. So I'll be having 2, 1 minus cos square x will be equals to 2 plus, now cos 2x, cos 2x, cos 2x. I can dissolve cos 2x to be this, to be what we have here. So I can decide to write cos 2x as 2 cos square x minus 1. So the reason for this is so that I can have a more uniform identity, trigonometry all over the place. So you can see it right here. I'm using cos in this particular one. You can decide to use sine. If you're going to use sine, look at how it's going to look like. Let me decide to put that of sine here just briefly. If I was using sine, then I would not need to change this at all, because this is sine. I will just say 2 sine square x will be equals to 2 plus, now this is what I will have to change. So I'll be changing this, instead of using this particular one, I'll be using this one. I will say 1 minus 2 sine square x. So that's me using sine. It will also still work. So whichever way you decide to move through, you will still get your answer. The major thing is to know exactly what you're doing. So I'm deciding to follow through this method, and you can go on to use anyone you decide to. Now, looking at what we have here, I can open this. Obviously, we have 2 minus 2 cos square x will be equals to 2 plus 2 cos square x minus 1. Now we have to go on to collect like terms and the likes. I can see I have minus 2 here. I can bring this one here, or I can take this one here, whichever one works. Let me bring everything here, and let me bring 2 here. This will be 2 minus 2 plus 1 equals to 2 cos square x plus 2 cos square x. This will be 1 equals to 4 cos square x. So 1 equals to 4 cos square x. So I can go on to saying that cos square x, I won't be wrong if I said cos square x will be equals to 1 divided by 4. And you see exactly what we're doing right here. So we have been able to arrive at a very good answer. What do you think we do next year? Anybody in the comment section, let me hear from you. What do you think we should do next year? Okay, somebody said he doesn't understand. What part don't you understand? I'm trying to understand where you don't understand. Yes, somebody said I thought cos 2a is cos square a minus sine square a. Yes, you are correct, but don't forget, I then went on to tell you that if you had cos 2a is cos square a minus sine square a. I then went on to tell you that you can put, for instance, knowing that cos square a can also be written as 1 minus sine square a, following this identity, minus sine square a. So this will be 1 minus 2 sine square a. This is another way you can write cos 2a. I told you there are 3 different ways you can write. So there are 3 different ways you can write cos square a, cos 2a rather. There are 3 different ways you can write it in terms of what you wrote and the likes. Okay, people are giving a good answer. Square rooting both sides, that's a very good one. So I take the square root of both sides. When I do that, I will be having, I take the square root of this. I take the square root of this. So what do I have? I have cos x will be equals to what? Plus or minus 1 over 2. Don't forget and don't ignore the plus or minus 1 over 2. And somebody else will decide not to write it in fraction, which is good because we're dealing with angles here. You can write it as plus or minus 0.5. So this is exactly where you then need to be very careful, because some people will go on to make some mistakes in this particular case. And I don't want you to. I think we can go home to rub this off. Now, we're dealing with cos x equals to plus or minus 0.5. So what we're going to do is we're going to do it on both sides for you guys to understand more clearly. I'm going to solve for when cos x is equals to plus 0.5 here. And on this other end, I'm going to solve for when cos x is equals to minus 0.5. So you can go on in your at your own side to try and resolve this, and let's see how you're going to fare doing this. So looking at what we have here, if I'm following this particular left-hand side, I can see my sign here is positive, but I told you that before you examine the positive or negative, what you have to first do is to say x equals to arc cos 0.5. What is arc cos 0.5, somebody? Arc cos 0.5 is 60 degrees. Good. So having 60 degrees, let me just write 60 because of the many zeros there. All right, now that we have 60 degrees, this is just an initial answer. We are going to now go and investigate using our quadrant. We have positive sign here. So where is our cos positive? Our cos is positive in both the first and the what? And the fourth. So cos is positive in both the first and the fourth. And what is the rule that operates for the first? I told you in this case, you just go home to replicate what you had here. That's x equals to 60 degrees. And for the fourth, we have the rule of 360 minus x, minus an angle. In the case where you are dealing with theta, it will be minus theta. You should be able to understand that easily. This will be 360 minus 60, which will be 300 degrees. How many of you have gotten something like this? How many of you was able to follow what we have here? Now, that is the two answers we're going to have for our positive 0.5. Those are the two answers. But that's not all we have to do for the other hand. Now, solving for the other hand, we can see that in this case, we'll also still find x equals to arc cos 0.5. Arc cos 0.5 will be x being 60 degrees. And for us to find our final answer, we ask ourselves, where is cos negative? Cos is negative in both the second and the third quadrant. And the rule that operates in the second quadrant is 180 minus theta. So in this case, we'll be having 180 minus our theta here is 60 degrees. That will be what? 120 degrees. And for the third quadrant, the rule that operates there is theta plus 180. That will be 60 plus 180. That will be a value of what? 240. So this was the answers gotten when we had our negative 0.5. So this brings me to a conclusion. I think I can now go on to conclude that for this particular question, my theta, or my hex rather, will be equals to 60 degree, 120 degree, 240 degree, and what? And 300 degree. So this is how you go about solving trigonometric questions. You have to, number one, understand all your identities. Number two, you have to understand the use of angle of any magnitude and ensure that you don't leave any stone unturned while trying to solve these questions. Like in this case now, you would have been wrong if you decided to just consider the positive 0.5. Now, considering both the positive and negative 0.5 is what gave you your perfect answer, which you can see right in front of you. So these are the basics of trigonometry, and I want you to ensure that you ask more questions and make sure you don't get intimidated by any question. All you have to do is to follow through on whatever the rule that you need to follow through on. So I want to give you a particular assignment before you go. I want you to make an attempt on this particular question. Please hold on. I will be writing it right on the board. I want everybody to ensure this is solved, and I'll be checking it out as soon as I can. So please just stay tuned. I'm coming. So you're going to get this assignment. You solve. Normally, we're supposed to solve this right now because I really love when you are able to apply the knowledge you just got quickly, as opposed to waiting longer. Okay, so let me get the board off so that you can see it right in front of you. All right, so let me see your solution to this question. I think on the contrary, I would love you to drop your solution right now. Let me get your solution like right now. Let me give you just 3 minutes to be done with what I'm writing. Just 3 minutes to solve this question. It's very similar to what we just did. So you can see what we have there. Cos 2y minus 35 equals to 0.891. And the given range for y is the same. Y being between 360 degree and 0 degree. So let me see people that have been paying attention right now. Oh yeah, move on very quickly. I want to get my solutions in a very few moments. Let me see who has the answer. Anybody with the answer yet? Across the same range. Okay, yeah. Make sure you blast these questions very quickly. Blast all these questions. These are very simple questions. Let me see how you fare with it. People are dropping answers already. Okay, that's nice. Someone said, I'm willing to see lots of answers rolling. These are okay, I can see your names there. So I want to know the people that are giving me the answers. Someone is saying 31 and 184. You guys are getting different answers. 31 and 149. Okay, it looks like 31 and 149 looks like the trend. Are you sure? So okay, 31 and 184. One and 329. 27 and 183. That's a bit distance from what people have been saying. 30 and 183. What's going on? 31 and 149. 31 and 329. Why are you getting different answers, guys? Why are you getting different answers? Okay, you know what you do? Go to the next question. Go to the next question quickly. Okay, I think I saw somebody. I believe the answer for that first question is 31 and 184. I believe this very first question is 31 and 184. Maybe we'll solve it. I'll solve it in another video, just for the sake of time. Go on. I believe this is the answer here. 31 and 184 seems like the correct answer for number one. Go on to number two quickly. Let me see what you do there. Go on to number two. 31 and 184. What's the next one? 31 and 184. Okay, I've gotten that. We're done with that. Let's move on to the next one. What's the next question? Okay, we are done with the first question already. Let's move on. Can we move on? I'm waiting for answers for the second question. We're done with the okay. Somebody said 8 and 188. Number two, somebody said 8 and 188. Okay, I'm seeing somebody else saying 8 and 188. Okay, I'm waiting for answers for question number two. So we have to be ending this class very soon. So you guys should just give me my answers and let's close up for the day. Okay, can you attempt number three then? I believe everybody gets number three. I believe everybody gets number three. Number three seems like the simplest. If you followed me in this class, you're supposed to ace number three very easily. Are people getting the answers already? Number three, please can you indicate wherever you're writing what particular question you're solving? 29 and 65 is for which question? Number three. Wow, I love this guy. Who is this person? Who is Clark? Condo Clark. I like the answer. I like the answer. Okay. Okay, who is solving number three? Please, can you just write number three and tell me what the answer is? Okay. Okay. Kudos to Victor. Kudos, Victor. That's nice of you. Kudos, Victor. That's nice of you. Okay. Precious Ogunwale. I don't know if I know that person. Okay. Precious Ogunwale. Seems like you're on point also. Okay. Precious, the other Precious, I think that's the class rep. I think I know you. Okay. That's nice. I think you guys are rocking it. Can I get more answers? Can I get more answers? Show me more answers. Guys, let me know that you are following me. Let me know you are following me. Let me get more answers. Okay. Anybody there still trying to solve? All right. So I think majority of the questions, if not all of them, have all been answered. So I would endeavor to try and bring a whole package for I will try to bring a whole package for trigonometry. This is just a class that deals with more of the application of so many things that we have been learning in previous classes. And I'll try and bring out a whole package for trigonometry as soon as I can. And I hope then I'll be able to solve more questions. Yeah, I think you're rocking it. I love those answers. Number three, very correct. So I'll try and bring out the whole package. So you guys should stay tuned for those videos. And now, can you give me feedback on how you feel now with these questions? Do you feel more confident in trigonometry? Are you much more better in it? Can I get feedbacks from you guys? How do you feel? Okay. And are we all with our identities? I'm sure by now nobody should be without the. Okay. Okay, we saw a mistake in the test. Okay, that's nice. Okay. So I just want to say the trick just deal. How we just deal. It's quite understandable. Okay, nice. Deal with the roots in the. Oh, okay. Or maybe in class or physically or probably later because of time. With those I think okay, we feel it's quite okay. Okay. All right. So guys, this is where we're going to call it a day or a night. 40%. Okay, you have 40% knowledge of trigonometry now. Okay, let's hope that probably while when new videos come out, you'll be able to increase that 40% to like 95%. Okay. So guys, thank you for joining. It's been quite a moment, and I love that you guys are making progress in all these topics. So we'll be having the next virtual class. That will be later, I think on Saturday and Sunday also. So would have would talk more on different other topics, or probably repeat some of the topics we have done. How many of you guys were in the class yesterday? I hope you are very perfect with mathematical induction now. I hope there's nobody here still struggling with mathematical induction. So what will you say should be the next topic to solve? Let me hear your feedback on that. What should be the next topic? What should we solve next? Okay, what should we solve next? Inequalities. Okay. Somebody say inequalities. Okay. So I believe everybody mapping, logarithm. Wow. Let's solve logarithm and inequalities. Okay. Looks like that is ringing more of a bell now. Let's solve calculus from the beginning, how it all started and all the deep stuff. Okay. Inequalities, calculus. Okay. Calculus, lots of calculus coming in. Yeah, calculus is going to come in grand style. Okay, looks like we'll be dealing with logarithm and inequalities at the point, because I'm looking at a lot of people writing that partial variation. Okay. All right. So next week class, we're having at least 2 classes also. We'll all be present, and again, so you have solved calculus before. No, we just started a bit of calculus. We've not done so much of calculus. We've not actually done anything in calculus. That was just the introductory part. Domain and codomain, those are just introductory part. We're going to go. Were you in class? That person that said you don't understand induction, we're not in class yesterday. I don't think anybody that was in class yesterday have issues with induction anymore. But again, maybe I'll be doing a video on induction, mathematical induction, and you can probably use that to raise up your knowledge. Calculus is very broad. You guys have not started nothing in calculus. You're going to see so much more. So it's really broad, and it's very, very examinable. So we have to take that very seriously. When we start calculus class, we're going to actually be going on a stretch with it. So let's try and solve every other thing before calculus, because when we start calculus, it's going to just keep going. We'll probably take like 4 classes straight on calculus, because it's a whole aspect on its own. All right, thank you guys for joining. Thank you. I really wish you guys the best. We'll see you in class tomorrow. Take care of yourself. Enjoy the night. Bye-bye.